Well, question number 6 from the 2017 AP exam. So let's go ahead and take a look. This is the series question from the 2017. This was a kind of a fun one to do right here. Now notice they're giving us some values. They're giving us f of 0, the first derivative is at 1, and then they're telling us that the nth plus 1 term is given by here. Now this is a Taylor polynomial or Taylor series question, so we want to remember how we get our rule for developing a Taylor series. Don't forget it's going to be, for a Taylor polynomial, it's going to be that the value of the nth derivative at c over n factorial times x minus c to the n. And what they're telling us right here is how we generate, for any power greater than 1, how we generate the top of our coefficient right here over the n factorial. So let's go ahead and read the question here. They're saying a function has derivatives for all orders where x is between -1 and 1. The derivatives of f satisfy the conditions as above. If the Maclaurin series will converge for all magnitude of x less than 1. So it's a Maclaurin series, so we know that c is going to be 0. That's going to make it nice for us. So that's going to be a 0 here and a 0 over there. We want to show that the first 4 non-zero terms for the Maclaurin series are the following. Now what's really interesting about this one, they actually gave us the series because we're going to use it later on. But they also want us to develop the series. They want us to develop this. Now they are talking about a series. There's a difference between the series and a polynomial. We'll talk about that again in just a few moments as we start going through here. So the first thing we're going to need is the value of all the derivatives. So we'll start with 0. The 0th derivative at 0 is 0. They tell us that. And they tell us the value of the first derivative at 0 is also 1. Now we have to do the value of the second derivative. We want the first 4 non-zero terms, so that one doesn't count. So we go f of 2. Now, we want to find the value of f, the value of the second derivative at 0. Well, that's be very careful. They give us this little rule up here. They tell us that the value of the nth plus 1 derivative at 0 is this negative n times the value of the nth derivative at 0. So what you got to remember here is this is really saying n plus 1. So even though this is a 2, n here is going to be 1. Remember, this is saying n plus 1 here. So what that's telling me it's going to be negative n. Well, if this is n plus 1 is 2, we know n is 1, and that's going to give us f of 1 of 0. Well, that's pretty easy to get. That becomes negative 1 times the value of the first derivative of 0, they tell me above, is 1. So we get negative 1. And likewise, if I want to get the value of the third derivative at 0, again, same thing. I'm going to continue the pattern. Remember, this is n plus 1. So I'm going to get negative 2 according to my rule, because if n plus 1 is 3, n is 2 times the value of the, take a look here, of n. Well, we know n is 2 of the second derivative. So that's going to give me negative 2 times negative 1. Remember, the value of my second derivative was negative 1, and that gives us 2. And if I want to find the value of the fourth derivative, same pattern. Remember, this is n plus 1. So we're going to get, so if n plus 1 is 4, that's going to give me negative 3 times the value of the nth derivative, which is 3, which becomes negative 3 times 2, which gives us negative 6 right there. And these are all non-zero terms, 1, 2, 3, 4. So now we're ready to generate our Taylor series. Now, we're going to generate the polynomial. For 2020, they only wanted to generate a polynomial. So we're going to generate the polynomial first. And that's going to be the following. We can use our little rule up here. We can use our little rule right here. And that's going to give us the value of the nth derivative at 0. Now, 0, 0, we don't worry about that one. We just go to our first one. So that's going to give us 1 over n here is 1. We don't worry about that one. That's a 0. So we can get 1 factorial, x to the 1, so x. And that's going to become minus, then I go to the 2, 1, because it's minus, over 2 factorial x squared, plus, I just keep the pattern, 2 over, that's 3 factorial, because now I'm on my third derivative, x cubed minus 6 over And of course, this becomes 4 factorial x to the 4th. Now, this is a polynomial. It stops. Okay, that's a polynomial. So my polynomial would be the following. X minus, if I simplify this, 1/2 x squared. If I simplify 2 over 3 factorial, what's that become? This plus x cubed over 3 minus, and if I do, what's that become? 6 over 4 factorial, that becomes 1 or x to the 4th over 4. So this would be my polynomial. As a series, this would be my polynomial. And this is for the 2020 AP exam. If in future exams, they will want the Taylor series, you would say f of x equals x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot, dot, dot. In a series, we need that dot, dot, dot plus, and then they want the general term. I can generate the term here. Remember, this is n equals 1, n equals 2. This is an alternating series, so I'll go -1 to the n. And what do we got here? X to the n over n. And plus dot, dot, dot. Now, for the 2020, we don't need this part. For 2020, we just want the Taylor we just want the polynomial. And then what they're going to say for 2020 is, oh, look, approximate at 0.1. But for all future tests, and the question's actually looking for is a series right there. So I do have both answers right there for us. We are going to be using this part in another question, though, in a few minutes. Anyway, so that's how we get that. So let's take a look at question B. Question B, determine whether the series, numbers they're talking about the series, in part A converges conditionally. Well, that sounds to me like alternating series. This is an alternating series right here. And remember, what we got for our function, our general term, when we looked at it, we got -1 to the n, x to the n over n. And I want to know if this will alternate absolutely or conditionally. So this is an alternating series. So what can I say? Well, the series alternates, decreases in magnitude, and the limit equals 0. This is an alternating series. These values are getting smaller and smaller and smaller. And therefore, the series converges by alternating series test. You will have to know this for the 2020 test, okay? So you get that question right there. And now they want to know conditionality. Well, conditionality talks about, well, it converges if it alternates, but what if it changes signs? Well, for that one, we can take the same series as we go from 1 to infinity, but now we're not going to worry about the negative part. The negative part just goes away. We get x to the n over n right here. Oops, don't worry about the x to the n part right there. Just so x to the n, x is a number right there, so we really don't have to worry about that. So we're really looking at the 1 over n right here. And this is harmonic. P is 1, therefore this diverges by P series. So this converges if only if the series alternates. If the series does not alternate, we don't worry about the x part. We really only worry about the n part, the 1 over n, because x is just going to be a number we plug in. So since P is 1, we know this series will diverge by P series, or just say it's harmonic if you want to. Harmonic. There we go. So therefore, the series will converge if it alternates, but not converges if it does not alternate. So we say this is the series the series just converges conditionally, only if the signs alternate right there. And that's worth 2 points right here. Not bad. All right, part C. Part C says now write the first non-zero term for non-zero terms for and the general term for the series given by the integral. So, well, this is not too bad to do. We're just going to plug it in. Now we're told really what this f of t is. If we go back here, we're told what f of x is. We're just going to replace each x with a t. And so that's just going to become t, whoops, what's that become? T minus t squared over 2 plus t cubed over 3 minus t to the fourth over 4 dt. And I integrate this. That's all. If we integrate this one, we hit g of x equals, what's that become? Oh yeah, x squared over 2 minus x cubed over 6 plus x to the fourth over 12 minus, notice I'm using x's and not t's here. AP's okay with that. Oh look, they misspelled the letter t. This becomes x to the fifth over 20 from 0 to x. Yeah, and we're just going to plus dot dot dot. Yeah, what we're going to get is x squared over 2 minus x cubed over 6 plus x to the fourth over 12 minus x to the fifth over 20. Now, this is a polynomial. To get the series, we would go plus dot dot dot. Now, again, for 2020, this is where we stop. For 2020, this is where we stop. But in future tests, they will want you to write the series. So we have to get the general term here, and the general term for this one, again, it is alternating. But we want to start off on a positive, so we go n plus 1, and we get x to the n plus 1 over, we get here, we get n plus 1 times n. And then you go plus dot dot dot. And that's how we get that one. So what they would give for the AP, they gave you 2 points for the first two, and then plus 1 for the remaining, and then they gave you plus 1 for the general term right there. So that's about a 3 or 4 point question right there. And the truth of the matter is, you can get 4 points for question C, and you don't even have to answer A and B because they already gave you the setup. Remember, all of this came from part A. So you don't actually need to answer part A to answer part C, and you can get 4 points. The national average in this question is only about 3 points. So you can answer a lot of points. Don't stress it. Answer what you can. But definitely try this one. It's a great question right there. All right, let's go part D. Last question right here. Part D says let P sub n at 1/2 represent the nth degree Taylor polynomial at 4, where G is defined by the function in part C. Use the alternating series error bound. Now, this is not on the AP in 2020, but you will see this in the future on stuff. So it's a good way to go ahead and remember how to use alternating series. Now, recall what they're telling us right now is that this little 4 right here, that is n is 4. So they're asking us to go out to the 4 terms. Go out to n equals 4. So if we go back, we're, oh, whoops, let me go scroll down here. They're asking us to stop at the 4th term right there. So we're going to say that g of x, to approximate g of x, we're going to use the first of the 4th. So we're going to use x squared over 2 minus x cubed over 6 plus x to the 4th over 12 minus x to the 5th over 20. Now, we want to show that the error of the fourth degree term is less than 1 over 500. So this is pretty easy to do. Well, this is alternating series. So there's my n equals 4, right? An alternating series says that the error in the first 4 terms is less than or equal to the next term, n plus 1, which is our 5th term, which is for us x to the 5th over 20. We use the magnitude. So what can I say? Well, the error in my first 4 terms, which for us, we should write it this way. We're going to write it the same way that they did. 1/2 minus the actual value at 1/2 is going to be less than the next term. 1/2 to the 5th over 20, which is less than 1 over 500. They don't expect you to know what that really is, but they right there. So, and then we will say, because the terms alternate, decrease in magnitude, and the limit equals 0. Therefore, our error in the first 4 terms is going to be less than 1 over 500 by the alternating series remainder. That's what they're asking us for right there, okay? All right, and that is worth a whopping 1 point right there. Really doesn't take too much work. I did a lot more work than I needed to. Really, you'll only need to look at that last term right here. So let's take a look at these. Try these. Ask questions on these, okay? All right, I will see you guys in class. And feel free to text me any questions if you need to, okay? Bye.